Hi, everybody. I have a pretty soft voice, but it's so quiet I don't have to yell that much. Thank you for being here. Welcome to today's Smart Safety Connection series. This is a series, so I do hope that while I'm super happy you're here today, that you keep joining us as we progress throughout the semester. So my name is Selena Disler, and I'm the program manager for the Safety 21 University Transportation Center. The Smart Safety Connection series is sponsored by the Safety 21 University Transportation Center as an opportunity for faculty to showcase their current transportation projects. It's also an opportunity for students, fellow faculty, deployment partners, and the broader community to engage and network with researchers, highlight opportunities for involvement, and foster future interdisciplinary collaboration. So please note that the session is being recorded. And for those of you who are joining us on Zoom, all of your microphones are muted. To ask questions, please send us a message through the chat box, or if you're here with us in person, just raise your hand. You don't need to wait till the end of the presentation. You can ask questions throughout. And now that we have all that taken care of, I'm really excited to introduce today's speaker. So Chris Hendrickson is the Hammerschlag University Professor Emeritus, Director of the Traffic 21 Institute at Carnegie Mellon, member of the National Academy of Engineering, and Editor-in-Chief of the ASCE Journal of Transportation Engineering, Part A Systems. His research, teaching, and consulting are in the general area of engineering, planning, and management, including transportation systems, design for the environment, construction project management, finance, and computer applications. So I think we're all really lucky to be able to welcome Chris today. So I hope you'll join me in a round of applause for Chris as he shares some lessons learned from the key bridge collapse.
So we're so happy to have Selena with us now. So can you all hear me in the back? Okay, we're all ready to go. I kind of changed the title on this talk on my last pass through the slides, and I added the word early because I think we're still in kind of an early stage of accumulating lessons that could be learned from the Key Bridge collapse. If I did this talk 2 years from now, it would have more material and more lessons that one might talk to. This is an early lesson. We're still within months, of course, of the collapse occurring. Disclaimer, I'm not a decision maker with regard to the response to the Key Bridge collapse. How this talk came about is that I got a call from the department head in civil engineering down at the University of Maryland who said, I'm organizing a workshop on the Key Bridge collapse, because they were very close, of course, to the Key Bridge and to Baltimore. And I'd really like you to come and talk about it. And so I said, oh, sure, what the heck. And so I put together a talk, and there was a whole program of people talking about what was known at that time. I came back from that and told my colleagues here in Safety 21 and Traffic 21 that I did this talk. And they said, oh, that sounds really interesting. Why don't you do it for our seminar series in the fall? So what you're hearing is the talk I gave back in May with some updates and some expansion to make it a little bit longer talk. So a lot of what I'm doing is coming off of media stories and agency reports, particularly the National Safety Board report, preliminary report that came out. So that's kind of my source of material for this seminar. It's not really my own research, but I've been trying to synthesize what's known. I do have a long-standing background in transportation systems. I've been kind of working in the area since the early 70s. And so, as you'll probably find out as I go through this talk, I have kind of a broad perspective on what issues exist for transportation systems. By the way, just as a sub-note, I'm one of the few Carnegie Mellon University faculty members with Seaman's papers. I'm an ordinary seaman. I'm not even able-bodied. It turns out in high school, I was working for a ferry that went between Seattle and Victoria, and I was helping to handle the lines for the ferry, and the Coast Guard inspector came by and said, "Does that kid have Seaman's papers?" And the answer was no, and so they sent me down to get Seaman's papers. Turns out to get Seaman's papers, you had to have a job, and to get a job, you had to have Seaman's papers. So it was a catch-22, but I managed to get through the system. The engineers should learn from failures, and there's a long tradition of looking at failures and drawing conclusions and changing how designs are done, how retrofits are done, how the systems are operated. So you never want to see a disaster happen, but we would all be remiss as engineers if we didn't take advantage of the disasters and collapses to learn and improve how we do things. And that's how engineering practice has evolved basically over centuries. So you look at collapses and things like that and try and come up with engineering improvements that can be made. By the way, I'm going to pretty much hew to kind of engineering lessons learned in this talk. You could do an entirely separate talk just on issues of finance and litigation and insurance and that type of thing. So I'm going to kind of avoid most of the financial implications of the collapse and kind of hew to the engineering aspects. And I give you 3 examples here. The Challenger Space Shuttle explosion in 1986. And there were lots of lessons learned, particularly about cold weather and what implications that had for spacecraft. The middle picture here is the 2011 Fukushima nuclear station tsunami. And that had lessons about both earthquake impacts and what the effect of long duration earthquakes are, and also a lot of implications for how nuclear reactors are designed. In particular, a lot of the Fukushima nuclear station had a lot of their sensitive equipment on the ground. And the idea was that, gee, a tsunami would never get into the nuclear station because the tsunami would be stopped by the walls. Well, that didn't happen. And so lessons are learned. By the way, in 2011, my colleague, Professor Jacobo Bielak in civil engineering, did a similar talk to this talk about lessons learned from the Fukushima nuclear station tsunami. And I still remember it very vividly. I went to that talk and I learned quite a bit about kind of earthquake. There are chairs over here if you want to come on in. The third one up there is the 1940 Tacoma Narrows Bridge collapse from wind oscillation. I saw a video of that in my introductory physics class as an undergraduate. How many of you also saw a video in similar circumstances? Raise your hand if you did. Yeah, a bunch of people. It's still being used. By the way, the Tacoma Narrows Bridge has shown up on lists of bridges at risk for not having protection for piers after the Key Bridge collapse. So there's been analyses of how many bridges are out there that don't have very good protection for the piers. Tacoma Narrows, the new Tacoma Narrows Bridge is on that list. And the media, as soon as the Key Bridge collapse occurred, pointed to a 1980 incident with the motor vessel Summit and the Tampa Skyway Bridge collision. And this it was the motor vehicle summit ran into the pier. There were 35 fatalities, so a major disaster. The 1987 replacement bridge, so 7 years after the former bridge collapsed, opened with concrete dolphins, bumpers, to mitigate collisions. And there were numerous media references saying, gee, why didn't the Key Bridge people think about putting in more protection onto the Key Bridge after this incident occurred in 1980? Well, that didn't happen, as we know. This is a picture of the 1980 bridge collapse. The Skyline Bridge is in the water. As you can see, one part of it is still there, and that's the motor vessel summit. Oh, a note on terminology. In the last 2 slides, I talked about an elision, and a elision is different from a collision in nautical terminology. In kind of media accounts, you always see the Key Bridge collapse listed as a collision. In nautical terminology, that isn't quite correct. A collision occurs when 2 vessels strike each other. An elision occurs when a vessel strikes a stationary object, such as a bridge or a dock. And so that's kind of a distinction that the nautical people want to make. By the way, every time I type elision, PowerPoint wants to go in and change it into illusion. So you might see illusion that I didn't mean to have in this talk as we're going along. By the way, there are all sorts of other vessel problems you can have other than elisions and collisions. There can be groundings, there can be explosions, fire, loss of power, and we'll talk about loss of power and foundering. In an elision, one of the implications is that the vessel is at fault. The bridge didn't jump out and collide with the vessel hit the bridge or the dock or whatever stationary object that it had. So that's the reason that the terminology is different for the 2 sorts of cases. All right, I thought I'd spend a little bit of time on the Key Bridge collapse. It happened March 26, 2024, so this year. We're still very current. The 947-foot container ship Dolly collided with the southern pier supporting the central truss spans of the Key Bridge going across Baltimore Harbor. Tragically, there were 6 fatalities from the event. They were all in a bridge maintenance crew. It was a bridge maintenance crew of 8 working on the bridge at the time of the elision. And two of the crew were rescued from the water. The other 6 perished. And there were 2 minor injuries on the Dolly itself, crewmen who got thrown around in the collision, part of the elision. This is what the Key Bridge looked like before. I should have said elision, there's collision. 50 years old. It has a central span with continuous steel through truss, and then it has lead up spans that are connecting into that centerpiece. That centerpiece is where all the action occurred. This I thought I'd spend a little time on. Can you all see this figure reasonably well? This is out of the National Transportation Safety Board preliminary report, and it's their narrative on what happened during the collapse. At 1:07 in the morning, the tugs let go of the Dolly. So there were tugboats that were aiding the Dolly in departing from their dock. And then when they got out into Baltimore Harbor, They dropped off, and that was standard procedure for handling a container ship. And then a little less than 20 minutes later, event 1 took place, and that's marked on the map here. A primary electrical breaker that feeds most of the dolly's equipment and lighting unexpectedly opens. The ship loses electric power, experiencing a blackout. So they lost power as they were going through the Baltimore Harbor channel. The diesel engine shut off very soon after. The crew restored power for a brief moment. The pilots that were on board, there was a senior pilot and a junior pilot to help the crew get it through the harbor, called for tug assist. Tugs actually did respond, but didn't get there in time to get to the dolly before it hit the bridge. Second blackout occurred at 0.5 there. And then there's a mayday that went out at 0.6, and then at 0.7 there, 4 minutes after the first blackout occurred, the dolly collided with the bridge pier. So this is all a very fast scenario in the middle of the night, 1:30 in the morning. It's not ideal for putting out rescue calls and that type of thing. You can see that if you see the orange trace, that's the trajectory of the dolly as reconstructed by the NTSB. It's headed straight through the channel when the power disappears. As the power comes off, wind and tide pushes it off course and towards the pier. And so eventually it strikes the pier with whatever residual speed was left after the power cut out. So that's kind of the main scenario of what happened. The NTSB went on to do, by the way, a pretty exhaustive survey of what was going on with the power system in the dolly. And so while it's not reaching any conclusions at this point, it's kind of looking like the proximate blame that caused this elision is, according to the NTSB, is likely the power problems associated with the dolly itself. Let's see if I can get this to work. This is the video of the dolly coming in, and this is the bridge collapsing. And it happened, as you can see, quite quickly. I think this is a real-time video. Can I see it again? Or what's up? No. Again. It's only a few seconds long. And of course, the tragedy here is that those maintenance workers were up on the bridge working on the pavement and didn't get off the bridge before it went down. And you can see how quickly it did go down. So one of the things about this collision is that the momentum of the dolly was very, very high. Dolly had about 4,700 containers on. Most of them had commodities inside of them. The estimate is 57,000 metric tons. The rest of the dolly was 112 in total weight, so the difference was about 47. New York Times had a nice little comparison. The dolly mass is roughly a third to a half of the Empire State Building on Manhattan. So it's a massive mass that collided. Uncertain about the speed. It was around 7 knots 7 miles, a little over 7 miles an hour. The other thing that, of course, the force of the collision depends on how quickly the dolly stopped moving ahead. The New York Times estimated it was 2 to 38 seconds, and so they estimated a wide range of how many billion newtons might have occurred. The New York Times compared it to a Saturn V rocket, the moonship rocket, moonshot, and it's right in that same range for what sort of forces were involved in colliding with the bridge. That becomes important when you start thinking about a redesign for bridges, for what sort of protection is going to be needed for this type of an elision. 18-wheel truck, by the way, hitting a bridge is on the order of 1 million newtons, so quite a bit smaller than this massive container ship colliding with the pier. This is what it looked like after the elision. You can see this is where the dolly has drifted to the left from the main channel. And you can see the debris over the bow of the dolly and debris blocking up the harbor. You can also see there were a couple of protection little dolphins out here. There's one right there, but the dolly didn't hit them. It just kind of scooted from going right and hit the pier directly.
Would it have stopped it if it had hit it?
Probably not. Yeah.
So it's just for decoration?
It would have slowed it, so it would have been less momentum, but I don't think it would have stopped it. I mean, that dolphin does not look substantial enough to have stopped there. This is a huge amount of momentum we're talking about.
As a quick follow-up to that, I assume it's because the dolphin was built and established when the ship's size was perhaps less, or is that just standard practice to divert momentum versus stop it?
Yeah, the idea was that was put out there in case something was coming straight at the pier. They weren't thinking about something drifting down like that. So that was a design from back in the 70s, essentially. This is a 50-year-old bridge. So this is an idea of the size of the dolly, and I took it from Wikipedia. Some R. Craig 09, whoever that is, did a nice job, I thought. You can see the length. The Empire State Building is about 1,500 feet. The world's largest, as of 2024, container ship is a little bit short of the Empire State Building. The dolly is shorter yet, a little under 1,000 feet. The 1970s era, which is what you were just asking about, what the designers were thinking of, you can see those container ships were quite a bit smaller. What's been going on since the 1970s is that the container ships have gotten larger and larger. The facilities to handle the ships have gotten larger and larger, like the Suez Canal has gotten larger, the Panama Canal has gotten larger, all the port facilities are larger, and it's essentially economies of scale that are pushing towards larger and larger ships. Similarly, the cargo capacity is going up, and again, that's an economy of scale sort of phenomenon. Okay, let me continue with the event narrative, and this is all, again, from the NTSB study. Oh, you okay?
Yeah, sorry over there.
Good news about this. The Mayday call from the dolly had police on the bridge who were there because of the maintenance activity. They had police stationed at the bridge. and they stopped bridge traffic. So remember the Skyline Bridge with 35 fatalities? Most of those fatalities were traffic that were going over the bridge. There wasn't that problem here with the Key Bridge. It was only the maintenance workers. I already said this, the tug responded, but not in time to reach the dolly before the collapse, and could help with rescuing the maintenance workers that went into the water. I already said this, private contractor was doing maintenance on the bridge deck, and they were on the bridge during the collapse, and only 2 were rescued out of the crew of 8. Another good news story about this is the emergency response was very quick. They had the tugs that got there pretty quickly, and then other emergency response came from the Mayday call. And so the Baltimore area emergency responders really did a good job about coming out. We already talked about this. The dolphins and the bridge here protection had little impact at all on trying to stop the dolly moving forward. All right, that's kind of the events of what happened, which is, there are lots more video if anybody wants to go and find it on the internet. Major impacts of the collision, and each of these impacts are things that you can think about. What are the lessons that could be drawn from these different impacts? First major impact, of course, are the fatalities and the injuries, and those are lifetime effects. I mean, the poor families of the maintenance workers that lost their family members is a tragedy. Demolition and salvage. There was a major effort to try and remove the collapsed pieces of the bridge as quickly as possible, to retrieve the containers that had been fallen off the dolly, and also to refloat the dolly off the pier and bring it back into dock. That was handled by and large by private firms under contract with the Army Corps of Engineers. And it really worked much faster and effectively than people thought at the initial stages of looking at the event. Port closure happened. You know, this bridge was sitting in the middle of the channel, and so the entire port of Baltimore was closed while demolition and salvage went on. Remarkably, the port completely reopened in 11 weeks after the collapse. It opened partially even before that. They had some alternative channels that they cleared, so that the main channel opened in 11 weeks. You read the media stories right after the collapse occurred. The port closing was a major story. There was a concern about lost wages on the part of workers, lost business, the port losing business, the speed with which the demolition and salvage occurred really took that problem out of the way. Interestingly enough, ships were diverted very quickly. The shipping industry responded very rapidly to find alternative ports for the ships that were underway towards Baltimore Harbor. And I kind of thought that they'd go to the nearest port, like Philadelphia or maybe New Jersey, but it turns out that the diverted ships went all over. They went as far down south as Georgia, went quite a bit ways north. They were all on the East Coast, and it all depended on where port facilities were available, where rail connections could be arranged, all that sort of thing. But within, say, 8 weeks, it became pretty clear that the port was going to reopen pretty soon, and so that sort of diversion stopped. So that's, I would say, a significant impact, but not a major impact. And one lesson is that the marine industry is really good about arranging those diversions. Another major impact is the traffic diversion from the Key Bridge. And that's going to be multiple years occurring until a new bridge is rebuilt. So that I'll have some more slides on the traffic diversion. Bridge reconstruction. You got to think about what design you're going to have, what are the parameters of the new bridge, and how it's going to be constructed. By the way, this is a 50-year-old bridge, so instead of doing the reconstruction after, say, 70 or 80 years, we're now doing it after 50 years. So it's just a matter of speeding up what was going to happen eventually. Lessons learned, I already said, we're still in the middle of trying to devise lessons from this whole thing. The final report of the investigation from the NTSB has not come out yet. And so that's going to be something that goes on for, I would guess, decades into the future. So let me talk a little bit, many stakeholder parties. All sorts of people are involved with this collapse and are involved in dealing with the collapse. You've got a whole series of federal agencies, the Coast Guard, the National Transportation Safety Board, the Department of Transportation is involved in, of course, reconstruction. State agencies, Maryland DOT took the lead in a lot of the response in terms of reconstruction. Local agencies, regional travelers were affected by the closure of the bridge. I already talked about the marine industry and the suppliers to the marine industry affected. Construction industry, courts and lawyers are going to be going for years and years on litigation associated with this. The people who need to think about lessons learned in particular are researchers and standard setting organizations. So what should be appropriate standards for bridge protection? What should be appropriate standards for power supply reliability in marine vessels? How big an elision do you want to try and plan protection for future bridges? Good research question for somebody interested in that sort of thing. And of course, the public and the media have quite a bit of interest in the Key Bridge. I already mentioned demolition and salvage worked pretty well. Private firms were hired and were very effective. There happened to be enough equipment that they could bring in terms of cranes and the like for removing material, divers, what all. They not only retrieved the pieces of the bridge, but even the vehicles from the maintenance crew that were in the water. Regional traveler effects. This is one that got a lot of attention at the time of the collapse, continues to get quite a bit of attention. There were 4 lanes of roadway on the Key Bridge, 2 northbound, 2 southbound. The average daily traffic was about 34,000 vehicles. So that means 34,000 vehicles had to be diverted to other things. 10% of them were trucks. Give you a little perspective on 34,000 vehicles per day. It sounds like a really large number, but it's not tremendous. Couple of local examples. Out the back window here, if there weren't leaves on all those trees, you'd see the Boulevard of the Allies Bridge, which is shut down for 2 or 3 years while they renovate individual members after they decided that there was a structural problem with that. People like me, of course, use that bridge quite regularly, and now we have got to go to other places. Well, it turns out that the traffic over that bridge is about 44,000 vehicles per day. So slightly more than the Key Bridge. But the difference with the Key Bridge is that it's isolated from alternative routes. So the Boulevard of the Allies Bridge here has some alternative routes close by. In particular, the Parkway is right there. Forbes Avenue Bridge is right here. The bridge back here that goes into Shenley Park is another alternative route. The Key Bridge was kind of isolated, and so there weren't a lot of alternative routes. Some alternatives for where the, I'm sorry, the other bridge I was going to mention as a comparison was the Fern Hollow Bridge. The Fern Hollow Bridge is on Forbes Avenue. It collapsed and was rebuilt in about a year. That was a few years ago. And it has about 22,000 vehicles per day that go over the Forbes Avenue Bridge. It also, by the way, has 2 lanes in each direction. And now the rebuilt bridge has not only the 2 lanes in each direction, but also a bike lane. So Fern Hollow a little bit lower, Boulevard of the Allies a little bit larger, but it gives you kind of a scale for those of you here in Pittsburgh about what impacts the diversion might have. Well, what happened to the traffic? It can divert to other routes. It can divert to other modes. So it could go air, rail, shared rides. It can go to other destinations. And you could always think about trips that are avoided, that aren't made because the bridge isn't there, and there are alternatives like telecommuting of one sort or another. So lots and lots of responses that travelers can make to the loss of something like the Key Bridge that they'd be using. This is a slide that Hendrickson, which keeps track of travel speeds as a data provider. This gives you average PM peak travel speed changes right after the Key Bridge collapsed. So the scale here, the yellow is a 10 to 40% drop in speed in the PM peak, so about 5 o'clock in the afternoon. And you can see that the impact was pretty widespread around the Baltimore region. By the way, this is the Key Bridge. That's now out of service, so there's no speed data there. And you can see that the next alternative route is way up here. That's what I meant when I was saying there aren't a lot of alternative routes. The good news is you can see some blue where the speeds actually went up. So, yes, Joy.
Does Hendrickson give post-collapse data only, or does it give historical pre-collapse data?
It does have pre-collapse data, so what this is a comparison to is pre-collapse versus post-collapse, and that's what they're showing us on this graph. So speeds went down generally in the area, but not by a huge amount. I mean, there wasn't, gridlock in the region after the collapse of the bridge, which is kind of what I would have expected given the volume on the bridge. And kind of the alternative routes also had a significant amount of capacity. The people who were really hurt, by the way, let me just finish and then I'll get to you, were the businesses that were close to the ends of the bridges. Those people, if you think about it, if instead of going over the bridge, they had to divert quite a ways to the west in order to accomplish their travel. And so the people who were most hurt by the Key Bridge collapse were the people close to the Key Bridge, which is exactly what you'd expect as a transportation planner. Yeah, go ahead.
How can Hendrickson data be more beneficial over and above Google data apart from pre-collapse data availability?
Enrix is a supplier to a lot of real-time data gatherers. Google is a little harder to try and get into the form that you need. So they're different commercial ventures. They're all working on the same idea. The idea is you get vehicles that are willing to give you information about their location and speeds, and then you can assemble that into useful information to market.
Thank you.
Yep. So, some observations of traveler effects. Maryland, where I was, had real-time data center for information feeds, so you can get real-time information if you want. Yep.
I just want to make sure I understand the previous slide. Was the reduction in speed presumably because of increased traffic conditions?
Reduction in, I'm sorry, I should have explained that. Reduction in speed, you've got traffic that's diverting from the Bay Bridge, so it's causing congestion on these alternative routes. The congestion then leads to lower speed, which, I mean, we're all familiar with that. The same thing you can see with the Boulevard of the Allies. I think we're seeing more traffic on Forbes Avenue when that bridge closed down. And so you're starting to see congestion and slower speeds on Forbes Avenue right now. And you can just watch, you can see that every day. So that's what the effect is. It's the congestion from that diverted traffic that's going on. And that's why it's a comparison to travel speeds before the collapse of the bridge and after.
Thank you.
Yeah.
Is that congestion effect still apparent like today? This is comparing March 26, 27 to the previous weeks?
Yes.
If we look now compared to previous weeks, is it still slower?
Yep.
Working out there?
Yep. I didn't kind of go into that, but yes. But what happens is that as people experience this greater congestion, they start making adjustments. They'll change what time they're traveling, they'll change their destinations, they'll change this and that. And so over time, the impact is going to be less and less, is typically what goes on. There's studies going on at Morgan State, actually. There's a team of researchers that are looking at exactly that phenomena and trying to get lessons learned out of that. So that's coming. Joy, did you have a question?
No, sir.
Okay. Okay, did I get everything?
Yes, thank you.
So, real-time data center. If the collapse had occurred, I don't know, 15 years ago, you wouldn't have seen that sort of real-time data availability to able to make operational changes. Something that's changed in the last 10, 15 years. And so it's an opportunity for the transportation managers to kind of try and change the system to accommodate the sorts of diversions that we were seeing. Congestion increased on alternative routes. We already talked about this. Less than 10 minutes on average peak hour. So we're only talking about a few minutes. But if you aggregate that over many, many trips, it's not just 33,000 trips. It's all the trips that were on those roads to begin with that were going in around the key bridge. They also experienced that travel time increase. So overall, many, many travelers. Alternative modes have opportunities. Boy, if I was Amtrak, I'd be trying to divert people to Amtrak because the Amtrak tunnel is still there. I already said this, local businesses near the ends of the bridge had the highest diversion costs, which is exactly what you'd expect from that. And I also said surveys and operational changes are still ongoing as more experience accumulates with what people are actually doing. Another terminology note. Not sure why I put this here. Was the elision of the dolly with the bridge an accident or a crash? Should we talk about it? Accident to me implies unintentional, unexpected, unavoidable. Most motor vehicle crashes are avoidable or the effects can be mitigated. So I don't tend to call them accidents, I tend to call them crashes. You can improve driver behavior, education, rules, enforcement. I don't know whether anybody knows, but the city council here in Pittsburgh is trying to move towards red light cameras to be installed, and that's a safety measure to try and improve safety on the streets. Partial automation aids, I think forward collision avoidance, active forward collision avoidance is really going to make a difference in the number of crashes that occur. Ensure proper vehicle maintenance. You get lots of crashes that occur because people weren't maintaining their tires, for example. Vehicle design, you can add airbags to vehicles to try and reduce the impact of crashes. And of course, roadway designs, you can see that happening all over Pittsburgh right now to try and reduce the number of crashes. Joy.
How has the rerouting of traffic impacted surrounding neighborhoods? For instance, have there been any increase in traffic incidents or crashes?
That's a mixed thing, and I do not have data on pre and post crash rates in the area. More congestion can have kind of two effects. First, you can get kind of rear end collisions and that sort of thing, but you tend not to have severe crashes because the speeds are lower. And so there's kind of it's a mixed bag there that you really got to look at. And I just don't have the data. Morgan State might have a better handle on that than I do. Yeah.
You're saying on the terminology, do you happen to know what are the policy or legal implications of the crash? Like, is it that? Do you happen to know the legal or policy or standard implication after the crash? Like, how did the crash impact like standards for, I guess, vehicles or for ships?
Yeah.
Sorry, like I just.
Yeah, well, one of the things that you might expect is that we're going to see some recommendations come out of the NTSB report on this, the dolly's collision with the pier. It wouldn't surprise me to have them come up with a recommendation to think about standards associated with power reliability on a ship. So that I can see that recommendation is possibly coming. We'll see. So just to finish up on that accident versus crash, was this elision an accident or a crash? It was certainly not intentional, but was it an act of God? Could nothing have been done to reduce this? And sorts of things, more reliable ship power. If that was imposed, maybe we wouldn't have had the ship losing power. The rules on tug assist are harbor specific. So if Baltimore said, well, we want the tug assist to continue all the way under the Key Bridge rather than just out into the harbor channel, maybe that would have made a difference. Another one that a lot of structural engineers are interested in is, could we have put in better shielding for the pier and prevented the collapse through that sort of thing? And so I think it's very conceivable that things could have been done that weren't in place, and those things might have had an impact on this incident or this tragedy. Yeah.
On that last point, the one of the slides you showed showed the anticipated or not, at the time of the construction, the size of the boats that the dolphins were designed to stop.
Yeah.
So given that now there was no way to anticipate the kind of ships that were going on, that would be going through the harbor in today's times. I know you said you weren't gonna go on the legal side of things as much earlier when you opened, but does that have any implication in terms of liability issues for what it was designed for versus the capacity that it now handles?
I absolutely agree with you. I'm dubious myself that you could shield a pier like the Key Bridge Pier effectively from container ships coming in at 7 knots or so. So that I'm kind of more hopeful that we can come up with other remedies. And other remedies, I'm going to come to this, but things like doing tug assist to go, through the channel. That may be cheaper in the long run to pay for the tugs than to build a whole bunch of shielding.
Right.
You had a question?
Yeah, do you think that any incidents are truly accidents, or do you think that every incident could have been prevented?
I think there are some that are accidents that nothing could be done. Those are the acts of God that I talked about,
So what would an example of that be? Just
hurricanes. Well, hurricanes, I'm not sure. Some damage from hurricanes is really an act of God, but some you can mitigate. You can build, hurricane-proof buildings and that type of thing. So you got to really be careful about, what really is an accident versus a crash. And I'm thinking specifically about vehicle crashes of one kind, or not a whole range of accidents that you can think about.
Yeah.
Go ahead.
Do they really need to rebuild the bridge if the congestion of traffic on affected roads decreases over time?
Ha ha ha. That's a very good question. And well, I'll come to this, and I better hurry up and come to this. But the state of Maryland has already accepted a bid for a reconstruction of the bridge, and really, as far as I can see, did not consider the alternative of not building the bridge. So that's a decision that's been made, and we can kind of look back about how costly the reconstructed bridge is, and what the traffic impacts are. That's all to be determined.
Thank you.
Okay, let me see. Some lessons learned. It took me, I've been trying to weaving in lessons learned, but there's a whole sort of things that might be done to avoid or mitigate the effects of this sort of an elision. More reliable power for vessels. One of the things that the NTSB report, the preliminary report, was asking was whether or not there was some indication of a systematic problem with the power supply on the Dolly before it left its dock. And so that's a question that I think will come up in the final report. And is there an inexpensive way to improve the reliability of power? It turns out power goes out on marine vessels quite frequently, but it's usually happening in a situation in which it's not hazardous. You're out offshore and you suddenly use power and you get it back on after a while. It rarely happens that you're going through a narrow ship canal, bridge underpass. Escort tugs through critical passages, I already talked about. Smaller vessels, I think that's unlikely. All the scale economies point towards bigger and bigger ships. Lower speed limits. The Coast Guard imposed a speed limit for Boston Harbor during the demolition and salvage activities of 5 knots. I think it was 5 knots. So that was lower than the speed at which the Dolly hit the bridge. Better bridge protection possible and whether it's cost effective. One I like is communications improvement needed. when you had workers up on a bridge like that, you need to think about how can we immediately communicate with them in order to encourage them to evacuate. And so clearly some better communication, say in the hard hats have communication devices, that sort of thing. So there's a possibility for a warning. May not have done anything in this case because the time was so quick, as I pointed out to you. But in the future, I think that's a lesson that we've learned from this.
You mentioned they dropped an anchor. Why didn't that work?
Momentum.
Because things have kind of.
Yeah, I mean, you think about an anchor. I mean, it needs to grind into the mud at the bottom of the harbor. Didn't have time to even get down there, I don't think, because the ship was moving along and it was dragging the anchor along. It takes a while for the anchor to get down. Major actors in these. Thinking about these lessons learned, ship standard setters, talked about power reliability, designers and operators. Bridge standard setters, there's going to be some head scratching about what sort of protection might be needed. I think beefing up emergency response to close off bridges is probably a good idea. Some of it's really good, like Fort Pitt Bridge has really good warning systems, but other places don't. Port standard setters and operators, there's probably going to be some thought about tug assist. Emergency responders, regional freight and transportation system operators, how do we react to emergencies? I kind of alluded to this, but one thing that's been going on in the last few months is there's been a request for proposals from the Maryland DOT for a private-public partnership to reconstruct a new bridge. Last week, so this is hot off the press, Kiewit Infrastructure bid was accepted, so they're the lead contractor and they're entering into an initial contract to do design work. The RFP included a wider span, which may have helped. A higher clearance to accommodate bigger ships, and some pier protection. Right now, the demolition of the remaining spans, you know, those approach spans that you saw in the pictures is planned. I wonder whether that's going to hold up when they start doing value engineering and thinking about, can we use some of this rather than just demolishing it? Financing is still uncertain. I've kind of avoided financing. For example, what will be the role of bridge tolls? President Biden pledged 100% support for rebuilding the bridge, and it's unclear whether that's going to actually happen at 100% or 80% or whatever. Right now, the original estimates were about 1.7 to 2 billion. Kiewit thinks it could be done for 1.2 billion. We'll find out. That's something to be discovered, but it's certainly a very, very expensive bridge. The goal is to finish it in 2028, and there are expedited permit waivers that are going on for environmental impacts. I said the tunnel wasn't of interest, and also not building the bridge wasn't of interest to Maryland DOT. Thought I'd do a quick comparison to our local Fern Hollow Bridge collapse. No fatalities on the Fern Hollow Bridge, but several injuries. Still in litigation, by the way. The NTSB did a preliminary report and a final report on that bridge collapse also. They basically faulted maintenance of the Fern Hollow Bridge over many years. So it was the responsibility of the city of Pittsburgh to maintain the bridge, and the NTSB thought that they didn't do a very good job on controlling corrosion. So they didn't worry about the vehicles that were on the bridge in their report. They worried about the maintenance practices on the bridge. And of course, the Fern Hollow Bridge is much shorter span than the Key Bridge. The replacement bridge occurred within 1 year and the cost was about $25 million versus 1 or 2 billion for the Key Bridge. Some really good news about this whole case. The signal from the dolly ship was received and bridge traffic was stopped. That was a big benefit. Emergency communication to maintenance workers didn't succeed. Dolly container ship was not much larger than ships envisioned during the design. Now, the risk of this sort of thing happening is pretty low. I mean, there are only a couple examples. Now, collisions between vessels and bridges occur pretty regularly. You can read about them here in Pittsburgh where barges get loose and collide with bridges on a regular basis, but usually it doesn't have catastrophic impacts the way this one did. And a lot of it was the momentum that was in the dolly. So this was a very costly. And that's my last slide. I kind of hope you got an idea about how one might think about disasters and collapses in terms of learning things. This is clearly an example of systems. I tried to cover kind of marine aspects, emergency responders, roadway, designer. And so it's a whole system of systems that was affected by this collapse. Need a broad inquiry. There's a nice website that Maryland has put up, Key Bridge Rebuild is the name of it, and you can Google it and go on and get any information you'd like. Or if you want to follow up with questions to me, my email address is cth@cmu.edu. I'm grandfathered into my initials as my user ID. Carnegie Mellon. Okay, any final questions? We're at the end. Yeah, go ahead.
Mr. Bettler had a comment that as another engineer who's been around CMU since the 70s, he wants to thank you sincerely for your incredible expertise, passion, and legacy of learning, which you have nurtured. You are renowned worldwide, but greatly loved and appreciated in CMU, nationally and regionally, and we are blessed to have you. Thank you for your work and presentation.
Okay, thank you all for coming.
As you walk out, I just want to say that the slides and the recording of this presentation will be posted on the Safety 21 website. And for any students in the room who are interested more about transportation, consider the Transportation Club. If you're not already on the list, find me and I'll add you to the list. And join us tomorrow for Safety Question Seminar. Thank you everybody for being here. Thank you.